So Clifford, this is part 2, kind of a follow-up for the first interview, and I'd like to go into more detail on some subjects. You never really collected samples directly from the streams coming off of airplanes, correct?
Not at all.
Okay. So your claim is really that this is stuff that's in these samples, which in itself is a problem.
That is the problem.
Then how do we get to this is stuff coming out of an airplane?
That would be basically a process of inference and deduction, of which you won't have the formal proof of that until you conduct that formal study and process, which would require direct access, basically at 35 to 40,000 feet, in multitude. There's many people that have tried to propose having a single occasion, and that would address it. A single occasion wouldn't address it at all. Actually, the simplest answer to that is to mandate, to force the collection of hundreds of HEPA filters from aircraft and analyze hundreds of filters, not take up a single sample. That would be the way to do that properly.
And why would the HEPA samples in an aircraft be useful to have?
They would be valuable in that they can collect, it will collect solid materials down to the micron size, submicron even a little bit, and then they'd be able to be subjected to analysis.
So they would be air samples in general at that altitude, but not necessarily a sample of that particular plane.
It's a sample of the air. It's a sample of the surrounding air, right?
At that altitude. Okay. But you could also have something that followed a plane and actually took a sample of the stream coming right out of a plane.
You could, but it'd be a very weak way to do things, because the final question is, what's the state of the atmosphere? The question is not what is the state. Unless it's obvious that that sample would have value, you may be running an isolated risk there of not really getting the information you need. A more representative example is, what's the state of the atmosphere?
So, and you've kind of helped determine that already when it comes to these metals, these metallic salts, and these biologics.
As a, quote, citizen scientist, that is the position I was in, to attempt to satisfy that need as best I could.
But if we wanted to make a direct connection between the stuff that you found and the stuff coming out of airplane X, following that plane behind and taking samples could be a way in your...
It's definitely a way. A cost-efficient way is a large number of samples first on the general state, and then you would go in for the isolated case if you felt it was just cause.
You talked about there being, again, metals, metallic salts, and these filaments that contain biology. Were there any other components that you came across?
There was a class of materials that you would call a gel-like material, more isolated earlier in the work, still curious, certainly, of what that type of material was. There are some suggestions what it might be involved with. But, I work with things that are repeatable over and over as much as possible, so that we know we have something reliable to work with. So there is another aspect there, but unless it repeats and shows itself, over time in large numbers, it's not something I can dedicate my life to.
Okay, but didn't you also find something that was like a erythrocyte, a blood cell?
Well, that's sort of an offshoot of the biological aspect, sort of a subdivision of that. But within that physical filament sample under a high-quality microscope, there was a cluster type affair. This was with a medical professional. In fact, he called me there. I may have made mention to that. He called me there because he was curious. And what's even more curious is that medical professional did not know what we were going to see. This happened at the time of viewing. He was not aware of what we encountered. And what we encountered during mutual observation of that sample was it would have like the appearance of a grape cluster, a cluster of cells. And it certainly caught his attention, anyone's attention. Now, it would be later on that his assessment would be, this would have to be through later communication, his assessment was that the most likely candidate that he saw in that particular sample was that of erythrocytes. Now that was sort of a remarkable statement for anyone to make at this point, because now you're saying that is a blood cell, that's a red blood cell. And he's saying something like it would be a freeze-dried erythrocyte. So he's the person that actually makes this claim, not me, okay? Now, I also recall during that microscopy session that he left the room. I continued to look under the scope, and I found multiple occasions of that. Remember, this is the first time he ever saw it. I'm there. While he's out of the room, I continue to look under the scope, and I see additional repeats of that same phenomenon. My work would have gone to the point where I started culturing work, an early stage of culturing work. And I started culturing with blood culture as a medium. I placed human blood within the culture medium, okay? And I studied these cultures. What happened in these cultures was a very, very unusual form of growth that took place. And I know how much blood I put into the culture, and what was happening was I had a growth process that was taking place.
But you said that you put in human blood, so wouldn't the erythrocytes be from the human blood?
The volume of production, blood cells don't grow in a test tube, okay? You don't grow blood cells in a test tube, not by any conventional measure. This would be what I call, and I mentioned at the time, be a holy grail of biology to be able to grow blood cells.
So you're trying to culture the filament. You have a human blood culture as a medium, and then you find that culture, the blood component of that culture grows.
This is right. This is what happened is recorded, and I have the photographs as best as I could collect them at the time, and they present a set of circumstances that require an explanation. And it's a very strange phenomenon that takes place. It takes place more than one time, and it gets to the point where I'm making control studies. I'm doing the best I can. What is the best image of a human blood cell I can make? What is the best image of what I'm collecting, okay? Following it through to the test of hemoglobin, which was critical. All the geometry is satisfied. A hemoglobin test ends up being a rather critical phase of that work. It passes that test also. Okay, now I'll carry on to the next stage of that work. I'm talking about where blood involved culture work. A second stage, go ahead.
One clarification question. So do you end up with two different erythrocytes? One is this kind of transformed erythrocyte that seemed to be a product of growth, and the other is the original erythrocyte from human blood?
Well, the issue is you couldn't tell the difference, and this is why you'd make your best assessment. This seems to be involved there. Geometry, biconcave, 6 to 8 microns, passes hemoglobin test. It satisfies the criteria. Now, the part that was interesting about what I would call the perfection of the cells, when you look at the studies I did, human cells will generally have some imperfections. Those final cells that were photographed as a test result, you'd call them like too perfect, I guess you would say. Perfect geometry, okay? And also varying size, okay? This is where the idea of reconstitution comes in terms of the idea of freeze-dried or desiccated process. The idea of an expanding size to a maximum is also taking place. So that happens. The other stage that I should mention is that I did then get involved with direct atmospheric testing using a more advanced method that I was curious about called electrostatic precipitation. Electrostatic precipitation is pretty phenomenal. It's simple in terms of how it's done, but it's phenomenal in terms of its capacity. Example would be if you do this and you were to blow a little bit of match smoke into a glass container, this process, you will see that material collect on the interior of that glass vessel within a couple seconds. It's just instantaneous collection into a surface that you can collect. I did that, and I used microscope slides within the vessel as a collection device.
Just for clarification, electrostatic introduces a charge, And some of the particles that are negatively charged go to the positive side, and the ones that are positively charged go to the negative side.
Right, right. So there's a separation electrostatically that takes place. So material collects on glass very easily. So I ran these I basically made an electrostatic precipitator. The photographs of it are on the site. I wrote a paper on it, certainly. And the most curious thing was I did examine those glass slides. And during that stage of the work, I satisfied the criteria again in terms of collection of a unique spherical biconcave structure, roughly. Actually, the reduced size would be roughly 4 microns in diameter prior to constitution. The method of constitution is also a separate issue. But what I'm saying is I had an independent environmental sampling process that confirmed essentially the same type of finding. Something is unexplained, it doesn't make sense, that's not supposed to happen, is repeating itself in atmospheric samples.
Okay, so the important thing is that you found, when you cultured and when you took the air sample, you find basically the same erythrocyte type thing.
This is what happened. This is what happened. It's a phenomenal period of a couple of years of work. That raised the ire of quite a few folks in terms of introducing that type of research.
In the culture, when you see this transformation happening and growth happening of these almost perfectly symmetrical blood cell type objects that you confirm contain hemoglobin.
Correct.
Is everything transformed to that, or do you end up with a bifurcation, that you have some of the original erythrocytes?
I can't distinguish at the individual cell level who's coming from where, other than the geometry. If the perfect geometry might catch your attention, I can't distinguish.
But do you end up with now a culture that has only these perfectly round cells, or
The final cultures would have been, hey, I started with this, I'm seeing something which is beyond what I started with, what's going on here? That was the end result of that work, and the result of that work was to say, there's something that appears to be very unusual going on here, folks. We need to now do the work. That's what it always is. Now we actually need to do the work.
you look at some point at human blood?
Yes.
Just to take a look at it, see what's happening
Sure.
with people. But there, when you look at human blood, you see quite a different story than these perfectly round erythrocytes, correct?
Absolutely.
Okay, so we get one result that ends up in the culture medium producing these quite perfect erythrocyte type cells. But when you look at people's blood, there's a bit of havoc going on, yes?
Severe damage is quite common within the samples that were taken.
So tell us about that, what you saw.
What you see is the blood is surrounded by a small coccus type appearing object, sometimes in great numbers, and then you see different stages of deterioration in that cell. An early stage would be, a very early stage would be a single coccus entity in the center of the cell. Second stage would be lining the perimeter of that cell with the coccus shape, so it's lined. Third stage would be penetration of the perimeter, where these are getting into the interior. A further stage would be disruption of the geometry of the cell. Next stage would be total breakdown and dissolution of the cell to where it's clearly non-functional as a cellular unit. And where any and all of these stages would have been repeatedly recorded and encountered over the years.
But was there also a kind of an abnormal clustering of these? blood
Sure,
cells?
yeah, you would. That's right. That's right. You would have a lot of clustering that would take place. Mm-hmm. Yeah, not a good situation at all. It wouldn't take much beyond common sense to understand the body's not able to work with what I saw at the more advanced stages, certainly. Interesting, I remember looking in books on cancer, state of the blood involved with prediction of cancer. Many similarities in sort of the state of the blood. What's unique here is you have a very specific entity that is identified in association with, and that is this coccus submicron structure that's the source of everything that you see.
Okay, so I want to talk about the coccus, and by coccus you mean a circular, right? Circular?
Yeah, yes, coccus is one of the three primary forms of bacteria,
Okay.
rod-shaped and spiral.
From what I understand, you are actually looking at, for the smallest kind of indivisible object that you could find that was also capable of replication. Is that
Absolutely,
correct?
this was a primary goal of the driving the research.
Okay.
What's the smallest thing I can see with the equipment that I have, and that interests me.
Okay. That actually is alive.
It's like a brick in a building. That's just there, first of all, and then you determine whether or not it's a biological nature with the culturing process.
Okay. And you found out that it was of a biological
Very
nature.
much so.
And that it showed life. It moved, it replicated, it
Replicates would be the culture requirement.
okay. And it metabolized as far as you could tell.
Produces metabolic products, significant metabolic products.
Which you then analyzed.
Yeah, absolutely.
Okay. And you were able to separate that little object in sufficient amounts that you could then segregate the DNA from it.
This is all true, a great deal of work. The Western way of working and thinking is to break things down into smaller parts. It's what we do. It's one way. There's other ways. But this is what we're famous at, is breaking things down into parts. And there's books to help you, tell you what those parts are, and it has value. It has value, and this is why it exists. Again, there may be other ways of looking at things, but the books have value. And so I studied the books, and I try to do it. You know, it's real interesting in science. One of the most difficult problems that anybody ever faces, and nobody ever talks about it, they think you just push a button and things happen, but they call it the sampling process. To get a suitable sample, okay, is a very big deal, very big problem. And now when you get a sample, then you have to learn how to break it down. These are not simple tasks for, let's call it an environment with limited resources. But yes, I mentioned at one time that there's four major classes of biomolecules. If you take anything that's living, no matter where it is, there's four things that you can break that down into. One is proteins, one is lipids, one is carbohydrates, and one is nucleic acids, or DNA. So everything you see, these four things are making it up. Well, that was my job, is to try to get it to these four divisions as best I can. And I did. To the best of my research. I broke it down into these four categories. Carbohydrates would be the weaker one of my set. But the proteins, well, they're all interesting. They're all important. But certainly proteins and DNA would be at the top of the list. But everything's important.
But it's not just that you classified it as protein. You found out what proteins were there.
Well, this is where you go as far as you can. Okay. Now, this is where you get involved at the molecular level. And I've made this point before, but it's fascinating. I can go to the level of visual. I can go to the level of an optical microscope, right? Then there's a lot of ground in between, but I don't get to work in that mid-ground. I don't have the equipment to work in the mid-ground below that. But guess what I can jump to? I can jump to the molecular level. So I skip this stuff in between, but I can make a jump into the molecular level, and how's that done? That's done with spectroscopy, okay? Particularly and specifically infrared spectroscopy is the big granddaddy there. There's half a dozen types easily you can work with. But infrared spectroscopy is an extremely powerful tool because the molecules will vibrate. When you subject them to that type of energy, they vibrate. And when they vibrate, we have tools now, and I was fortunate enough to be able to acquire one that can record that vibration. And that vibration will tell you something about the way that thing is made up. Okay, it's a very powerful information. It determines what are called functional groups. These are core entities of chemical structure, and they are responsible for the reactions that take place. All chemical reactions are tied into these functional groups, and if you can get some information about these functional groups, you get an idea of what this thing might be starting to do in the body or in any kind of chemical reaction. So yes, many years, many weeks and weeks on end, roughly probably 1,500 spectra were collected. Everyone has to have a proper sample prepared. You have to know what you're working with. You have to develop the methods. I probably have 1,500 spectra that tell us a fair amount of information about what the nature it is of what we're speaking of and what it's likely to be doing.
So we look at this sample and we find metals, we find metallic salts, we find filament structures, but we also find this cluster that you talked about that's like a raisin cluster that has these round things that you later determine are erythrocytes.
To the best of the information available.
Right.
Correct. I always qualify everything.
But what is making up the cluster part of this? We know that the little grape is there, that's these erythrocytes. Are these clusters the filaments, or is it something?
No, this was a distinct entity, biological entity, okay, that was within the sample. This is like something, it's like it wasn't perfectly homogeneous. You had the introduction of another class of materials that would raise a lot of questions about what are these doing here? Why is there a cluster? Why does it repeat?
Okay, but there's like this network of stuff that's connecting these erythrocytes together. Is that correct?
That's right. This would be the appearance. This is our appearance at this point. Yes, and by the way, I'll mention there were some other biological structures there too, also unexplained. That the photographs are there. It's like my work is to present. Photographs are there under the good quality scope was being used. A very good quality scope was being used there, and those images are there. The medical professional statement is there.
So you're not sure what those other things are?
No, this thing raised, what do? I have to be fair. The title of this paper? Something to the effect of biological components identified, okay? Sounds specific, right? But it's not specific at all, right? It's telling you there's a lot of things here that we need to know, folks. Okay? What do you mean biological components? Shouldn't you be curious?
Okay, so we're getting to a very good point of clarification. In this sample, metals, metallic salts, these filaments that contain this little round circular thing that ends up, we're going to talk more about, and then this cluster that has associated with it erythrocytes that are kind of in a network that's connected. But then there's other stuff too that remains unidentified.
Absolutely. I had to make a decision in the work between where I was going to spend my time and effort. Single person, limited resources. You had a geoengineering aspect that evolved, and you had a bioengineering aspect that it was evolving in a very unexpected and unknown way. If you notice on a very general level, you'll see a great deal of attention spent on the geoengineering side in the earlier years. We have a total span of roughly 20-some years, right? You have quite a bit of work on the geoengineering aspect. But within it, from the very beginning, you're going to say, it looks like there's a significant biological aspect going on here too, right? All right. At some point, you get to a level of work where you have both existing. A lot of work and investment has already been made. I had to make a decision about where was I going to put my time. And it wasn't easy, but I will tell you what my reasoning process was. The reasoning process was, I'm going to shift the work primarily into the biological aspect, okay? Now, that was done for the following rationale, primarily. You have a problem which is much bigger than any single person can even begin to address. But I had to say, if I had to choose one thing, what would be the most important and why? And my rationale was that the simple answer is, you can't fight if you're sick. That's a simple answer. If you are sick, you can't fight. You can't find out what you want to know if you're sick. You can't perform, you can't object, you can't do anything properly if you're sick. And so I decided that of the time and effort that I could place, I would be best served by trying to learn what it was that would make us sick. Because the truth is, we do need to fight. That's the honest answer. We need to fight. Now you can interpret that in a lot of ways, but at the most elementary level, we need to fight for our survival.
Okay, but the point is that you knew enough or suspected enough to realize that whatever was in these samples could or was making us sick.
At this time, I would already have been doing blood analysis, and I knew there was a very serious problem in place. The state of the blood that I saw, I have to say, I would wonder how a person could even be alive or function under states of the blood that I was seeing. And again, my samples they're limited, but I did the best I could. They were enough for me to say, this is a really serious problem going on here because that body can't even function the way it's supposed to.
So we have this very small, circular, what you've described as kind of cross-domain bacteria that exhibits characteristics of the three major life domains that you find every time you look at the blood and where there is distortion of those blood cells. It is involved. This agent is involved.
No matter where I go, again, where was my attention, right? And no matter where I went, trying to get to the core and the source of a problem, no matter where I went, across the board, when you accept that the biological aspect is of great importance here, that smallest identifiable unit was the focus of my attention, was and remained.
You made the conclusion because you saw it every time. It was there when there was this formation.
Yes, it's a deduction that this is a source of my problem.
Because it was present every time there was a problem.
Absolutely.
Okay. And it exhibited itself in a number of ways, like you said. Sometimes it was inside the cell, sometimes it was surrounding the cell.
Sometimes it was in the filament, sometimes it was adjacent to the filament. It was in every biological sample examined. It was everywhere that I went. But the blood was the grand central station of knowing, blood is easy to isolate by itself.
Looking at this blood sample, the filament isn't necessarily there, right?
Good choice of words, not necessarily. Interesting case, there are cases where filament structure showed up within the blood, and that was very deeply concerning. My biggest concern there would be to try to ask, is there any possibility of contamination? I'll always allow for that possibility. But I saw enough cases of it to where I don't think contamination from an external source was sufficient to explain what I saw.
Okay, so there are times when you actually see the filament in the blood.
I did, and that was very concerning.
And then but then most of the time what you're seeing is just this very small unit that was in the filament, in the blood.
Absolutely correct.
Independent of a filament.
Correct. A coccus form is granddaddy. Reaching a state of successful culturing is a monumental achievement because it gives a person the ability to sustain and control and repeat the process. It's a huge, huge achievement. So once you have that culture...
And potentially isolate.
Yes, it serves as your material to work with, but now in a controlled environment. So once you have this, everything changes. And like I say, that advanced stage of culturing really changed things quickly. But you have material to work with. So now where are you at? You're after those four. Can you get any of those four components separated? That's your first breakdown, right? Of anything alive, doesn't matter what it is. So I succeeded in that to a degree with a great deal of effort. And so you have tests in place to see whether or not you have a protein or not. There's tests that you can come up with. You can do it spectroscopically, you can do it chemically. You have tests that you design or see whether or not you have lipids. Lipids are fats and oils. You have, you're going to have to me, the nucleic acids, could I get DNA from this? Carbohydrate, again, I'm letting that one from the side. It's right now the least important to me. But I'm going to say that yes, that process of separation took place where I could see 3 fundamental units that were there to work with.
Those fundamental units being the protein, nucleic acid, and lipids.
And carbohydrate, the 3 of the 4 that I focus on. Carbohydrates is another you would pull in at some point. Okay, once you have these, this is a starting point. That's a major achievement. But it's just the start of what needs to be done. And it's always, no matter what I'm talking about, it's always just the start of what needs to be done. Because, I mean, do you realize how many, if I took a sample of a part of your body, do you realize how many different kind of proteins you would have in it? I'm saying I isolated what I know had a protein in it. How many types of proteins are in it? What's the nature of the proteins, okay? And why are they important? Why are proteins important? You need to know the structure of something to know what it's going to do. Skin protein is different than hair protein. Do you want hair and skin? Yes, you need them both, right?
So there's a direct correlation between structure and function.
Yeah, absolutely. This is the heart of proteins, okay? It's what gives form to things. So you need this information. I know there's proteins, but in terms of I have very generalized information about these proteins. You have, proteomics is the word. You know how you have genome? You have how many billions of dollars for a genome project, right? Same thing is going on with proteins. They're incredibly complex, and they're trying to work on classifying proteins by their general character, right? What's their nature? There's no end of analysis. I know we have proteins. I know I could make this jump down to the molecular level to get functional groups that are likely tied with this. But what gets fascinating about this is I know I have 3 broad categories of metabolic products visually. I'm not talking about the chemical definition. I'm talking about visually, macroscopically, 3 different structural forms that show up. One is a liquid. One is a solid. The solid is extremely complex. You don't have, there's so much going on there, we don't have the slightest idea yet. And then you have the filament, the direct entity. Yeah. 3 visual things, okay? Let's just take one to show you the problem I'm up against. That soluble form, I spend a lot of time with that soluble form, because when something's soluble, you can work with it. You can do, most of chemistry involves solutions, right? So I spent a great deal of time on this liquid form of metabolic. That thing is fascinating as heck in terms of what's going on there, because it's the complexity has to be just absolutely amazing. Because there was a time when I took that liquid. And which was pure. I mean, when you look at it, I went through a purification process. It's clean as can be. It looks simple. You think you have a single thing. I then went through a process of chromatography with that. I have a dozen type of separations that I made within that. They're all recorded. I'm saying this looks unique, and this looks unique. And how you know they're unique? Primarily through spectroscopy. You can take each one of these things. If you take vinegar and you take glycerin, and you put them under the infrared scope, you're going to see a total difference in the way they're made. I have over a dozen constituent components of what I'm calling a single metabolic product on a visual level. Okay, this is one of the 3. Okay, I can now say what the heck is going on with the solid thing. This is where if something has structure to it, you know it has a strong protein component to it. You know that there's proteins in there. But to even begin to know what's going on in there, it's just like, and the DNA, okay, my goodness, do you see what we need to know? I'm just telling you, I know enough to know that you need to know. Okay, and I'm trying to point the way. Yeah, the work is incredible in terms that it says this was accomplished, but it's just the beginning of what needs to be done. And I'm trying to say we are all responsible. We are all responsible and accountable to know what is there.
Well, Whoever's putting it in the atmosphere probably knows what it is.
Well, there is a very sophisticated level of design and intelligence that is behind these findings. How's that for a modest statement?
Did you ever do any research or some thinking or investigation of how this stuff is integrated into jet fuel?
Yes, I can think about a lot. We can entertain some ideas, okay? Quick ideas. If you're working at the submicron level, and nano, which I couldn't see, but every reason to suspect it's there. When you're working at the submicron and nano level, you get to do a lot of things, okay? A lot of things that you can't see unless you have the means to detect them at the submicron or nano level to begin with, okay? Once again, do I have access? No, but I know that you can do lots of things, okay? You can mix, you could have something in solution and you wouldn't know it. You can't see it. Okay? Could that include fuel? You start looking into jet engines, okay, and whether or not they could tolerate something in the fuel. And yes, it would be possible they could, okay? But nothing here is enough to explain everything that's going on because you don't have access to all the information. The other curiosity, you know, there's a photograph, one of the early photographs, showing this the filament material, the material that eventually went under the microscope, with that health professional. That's the first time that got under the scope. That material, it looks to me like it's roughly a ½ inch in diameter. It's visible. It's a ribbon of material on the ground, okay? Now, the logical conclusion is, knowing now subsequently that these filaments are microscopic, difficult to see in most cases, the logical inference is something screwed up in the system there. It wasn't intended to come down in a ribbon form, but it did in this case, very early years, right? Well, you're not doing that at the microscopic level within fuel, are you? You have some kind of system that delivered a ribbon of material composed of what you think are thousands and thousands of individual filament or fibers, but when you get it under the scope, it'll be such that whatever you thought was a single or two filament is ending up being another 100,000 filaments. So the fact that it is congealed and in a ribbon that's, you know, a ½ inch or a ½ inch across and 20 feet long, I'm sorry, that's a system, right? That's a system of delivery that looks like it just didn't quite work the way that it's supposed to. So lots of things can be involved here. But again, just get the answers you want in the proper way and do the right work instead of speculating forever about you can't prove and you can prove such and such. Just do the work. My work is focused where I can show by, I would say, reasonable analysis and methods and present a case to you that something's really rotten in Denmark here.
So you mentioned before that you've concentrated on the what for 20 years.
Yes.
And also, even though you did have a background in science, in math, you had to learn a lot as you went along, right?
I had to open myself to essentially every discipline under the sun.
But the point is, part of what you did over the last 20 years is when you had a problem, you didn't know enough about it, you actually went and learned a lot about that discipline so that you could then proceed.
Yeah, I had to. You know, I had, absolutely. You know, I sort of pity the people, you admire and pity the people when you think about the common route is to spend your whole life being a certain profession, right? Like when I took my first spectrograph, okay, and start to study this, and I realized this is a whole career. A whole life is to be here to try to learn to understand what this is showing me. Okay, and I acquired a library of a dozen books with tables galore and computer databases to try to learn what I could about this. I'm finite. My existence on this planet is finite. Okay, I didn't have the luxury of a career spectroscopist. I did the best I could, but this is the case for a dozen disciplines. No discipline would I consider foreign to my consideration. I think that I made inroads. I will say that. You've got a job to do in addition to the job I'm doing. And the job is much, much bigger than you might ever imagine.
You said one of the reasons you focused on the biology was because you had a very strong inkling that it was something that could make us sick. You go and take a look at the blood and you see a transformation that is not healthy in the blood. What we get, you take a look at the fibers that are coming out of people's bodies as part of this Morgellons syndrome, and you find out that they're identical to the fibers that you found in your samples. What other ways have you found or suspect that this cross-domain creature is making us sick?
Okay, this is a great one because there's another, I would call it significant body of work that exists that is completely and totally unaddressed and is so obvious to me in terms of direct laboratory evidence. I did what I would call toxicology studies. Remember when I mentioned to you about one of these metabolic products is a liquid form, okay? And it is soluble, it's water soluble. That is a big deal because that means, well, your body is like, whatever, 80% water. Most chemical reactions take place in water. So if you have something solid, this is a huge division already in chemistry. Can something dissolve in water or not? This can dissolve in water. That already raises problems. I engaged in what I would call toxicology studies. Now, this was a little difficult because I realized that I had ethical considerations that would come to play. I wanted to know, do I have any direct evidence how this might affect life and biology? But I had to do it at a level that was not going to, let's say, raise concern about the ethical application and issues of this. It becomes a tricky question to work with. I will tell you what I know is needed. What are needed are the classic clinical studies, right? And, you know, mice and whatever, this would be a very classic, simple thing to do. I then said, what happens if you subject living organisms to this solution? And some examples of that would be plants, okay? Other microorganisms, okay, and other and protozoa. I could safely work with these, I felt, without raising the, elevating the concern about the ethical issues that might be involved. In other words, it seemed like fairly safe territory.
Okay. And the ethical issue is doing experiments on humans that might have a deleterious effect on them.
Yes, this will be the ultimate stage that we would need to get to. I'd be more than willing to compromise at anything above what even everything came into the picture. Fish, amphibians, everything. But I chose the most elementary forms I could.
Right, and you exposed them to this liquid component.
Yes, and there's a big question there about concentration. Again, I try to be fair in my work, okay? If you eat too much steak, it'll kill you. If you drink too much water, you can drown, right? Everything is a matter of dosage, is important. So you have this big question about, well, how much? I will tell you that I made what I would call a rather modest solution. My answer is I used a 0.5% solution. Okay, 0.5% by volume, actually by mass. So I created, I have this metabolic product, I dilute it, right, down to 99.5, and I start subjecting living things to this. And I start with some seeds. I tried probably 3 or 4 different types of seeds. I went through the classic germination thing that you do in school as a kid and put it in the glass tube with a little paper towel and germinate the seeds, right? I did that. And I had my control studies that did not have this added solution, and those it did.
What happened?
It's a very sad result, actually. It's very sad. Sadder than, I'm sorry, any of us would want to know. But those seeds did not germinate, okay? They either came out highly stunted or they did not germinate, okay? It's really bad news.
Okay, so you're actually getting a little emotional over this.
Well, it's very bad news. What are you talking about? Sure, I'm presenting the evidence, but do you realize what you're saying there? Okay? I'm saying at the most elementary level, separating from the ethical issues, I'm trying to say, can you just see if something is happening and try to be conservative and modest in your approach? And the darn seeds wouldn't grow? Again, as I said in blood, what do you need? I can get angry sometimes, and I can get emotional sometimes, and I usually do it and keep it to myself. And I'm sorry, I don't swear, but do I want to swear sometimes? Yes. Okay?
What other living things did you
So I did several seeds, and they either the growth is stunted terribly or they don't germinate. Okay, you immediately have to start asking, have we impacted the reproductive nature of biology, and if so, to what degree, right? Okay, I did it to yeast. All three of these cases are very interesting. I took the class yeast, and I subjected them. So yeast are singular cells, microbes, right? It's another form of microbe, single organism. It'd be in the fungal category, right? I subjected them. What happened to them? Again, these images are on the site. I am astounded, honestly, when I talk to you about comprehending the importance of something. I am astounded that I can present those images and we're not at a place where we can say, I want to understand, I want to comprehend the nature of what is happening here.
What
okay?
happened to the
Because
yeast?
the yeast cells, what happens with them is they mutated. Okay, they mutated. The controls are there.
Into what?
They split in. They're single-celled organisms by definition, right? They split into two cells. They frequently form a joined two cell, like a twin. Okay, they formed a mutation. They had a mutation. Look at the controls and look at it's. What's it say? It says there was a genetic change that took place. Is what it says. It's a mutation. Okay. Bad news again, right? What am I saying? Reproductive capacity and growth capacity of life on the planet as we know it may well be affected. Genetic constitution may well be affected. You cannot restrict it to those single samples. You have to extend your conceptual argument to all life on this planet, especially when any single test that you run shows no violation of the results. There's one more to cover. The last one is paramecium. It's a little bit more interesting and advanced because things that move catch our attention.
Right.
Common sense is anything that has motion has the equivalent of a neural system. However primitive, there's a neural system in that organism. And I will tell you,
stimulus and response.
the behavior was the behavior was erratic. The behavior was like an organism that had no sense of deliberation control anymore. They were messed up, okay? They were messed up severely, okay? It's like you could equate it to somebody having an epileptic seizure or something. They were totally out, okay? They were not functioning microorganisms at this point. Bad news, really bad news in all three cases.
So a quick question about the solution that you used to test these three different objects, well, the seed, the yeast, and the paramecium. So there was water in this solution, correct?
Yes.
And the control was just water?
Yes, yes.
And so there was water and also these proteins that you had isolated.
Yeah, if I can back up and describe what the general nature of what we're working with is, and that is to understand the source, the culture medium itself, the most favorable culture medium. It can be done different ways, but the most favorable cultural medium is liquid. It's water-based, okay? Not all cultures are that way. A lot of them are solid and agar. This culture, the successful culture, is water-based to begin with, okay? Now, what this means is the dominant component within the culture result is water. The culture is water-based. It's dominant water. Dominantly water, okay? Within the culture, you have three primary forms that will show up. One will be a completely soluble product. The other will be a solid material. And the third will be, and that solid material is complex in terms of its appearance as well as structure. And the third is a filament structure. Now, the toxicology studies were done with the liquid product from that culture.
So these other things are separated, they precipitate out?
Yeah, I can keep them separate easily. What I did was purify and separate, yes, process separation, what the liquid component was. That liquid component, and now it can actually be concentrated to various degrees.
So you can adjust the concentration by basically adjusting the water content.
To whatever I want, and I can eventually turn that into what would look like a tar solution if I want to.
But it's basically by adjusting the water content,
yes,
right? Okay.
Absolutely. Yeah, it's a water-soluble product that I know contains protein.
Okay. And do you know at this point what the various proteins are, or just that there are proteins?
No, what I know are some of the functional groups. What I do is I have to jump right into infrared because I don't have all the in-between material. I know on a molecular level what the functional groups are that are involved. You have a few elements involved in a way that are very important in determining reactions. That's the basis of them, okay?
And in organic chemistry, there's not that many molecules involved.
No.
Elements, but the way that they combine.
Yeah, that's everything. Yeah, one little tweak here changes everything. So what resulted in this case was a purification of the liquid component of the culture. And then that solution was diluted to what I would call a pretty modest level at 0.5%. Okay? And you had control, and you had a specimen that was subjected to the 0.5% solution. In this case, call it a mustard seed, whatever seed was under investigation. And you watched the germination process unfold over a period of several days to compare them. And the photographs are what's presented on the site. And the same thing was done to apply to yeast, and the same thing was done to apply to protozoa.
So let me ask this question. This has been going on for 20 years, this dispersion.
22, and actually we can trace it back, there's no single date, but I can easily actually trace it back to 1993.
So it's well over 20 years.
Well over.
Okay. And it's pervasive. It's everywhere in the globe, supposedly.
Well, it wouldn't be supposedly, it would be by, again, logical deduction. Atmosphere is a fluid medium. Everything will disperse eventually.
Right, but we also have pictures from lots of other places on the planet that show these.
Everything says it's a global transformation.
And it's been going on for a period of time, and you have shown that this thing creates havoc. How come life is still going on as it is on this planet after 20 years of this stuff?
Well, remember what I said about dosage? Life is full of degrees in many ways. All those degrees exist. Some people die. Some people do fairly well. Some people appear to be doing very well and may not actually be doing very well. That is a very involved question that does not get the simple answer that we want. Oh, black and white, cut and dry. You're either like here or you're not here, or you're obviously sick or you're not sick.
So you're convinced that there's transformation going on the planet that probably affects all aspects of living things, all aspects of biology, but that they may be in different stages of transformation, and therefore different stages of effects could be seen.
Yeah, I would latch on to in terms of effects. The transformation is something that is a little bit more questionable. It's one of the areas that you would have to dig into, but in terms of effect, yes, everything is consistent with variable effects in a zillion ways, depending on a zillion factors. Life is not that simple to expect something so cut and dry.
So the point is that it's very possible if we studied this phenomenon, we might find that it could have been the cause of death for somebody, or it could be just it could be something as simple as that somebody just doesn't feel like they have as much energy as they used to.
Absolutely.
And anything in between.
Oh, absolutely. Absolutely. And I have pretty direct evidence to show that both those extremes are happening, as well as everything in between. I mentioned at one time in one of my projects, it's really sad. But in this small organization that I was and have been managing, I mean, no resources of any kind, that I have, it's like at least a dozen people, I don't count them. I have hundreds and hundreds, if not thousands, but hundreds of emails, people telling me, they're basically telling me, I'm sick, I'm in really bad shape, can you help me? And I'm in this position, okay? I can't help them on an individual level. I can help them with my research. The best I can do is to try to help. Remember the old Spock statement in the movie? Needs of the many outweigh the, right? I do the best I can. But at least a dozen emails come to me and they say, I'm dying. I am dying, and they know why they're dying. I'm not going to debate that here, but they know why they're dying. And they understand that I know why they're dying. And they're telling me, I want to give you my body. It's just a horrible thing. Okay?
Let me ask this question. If there has been this effect on biology on the planet, how come there are still athletes that are breaking world records and so on?
Well, again, when I say continuum, I mean a continuum, okay? And you always have extremes, right? And one thing I'm very careful of, in fact, it's an argument that's frequently used to try and dismantle the substance of any kind of work that takes place, if you have a motive to do so, is to take the isolated cases, okay, and use an isolated case as somehow a representative of the failure of the system of logic. And that's a flawed process in its own right, okay? When I say continuum, I mean continuum. And you can take an electromagnetic spectrum, as a continuum. And I can ask you, how far do you want to go? And I will tell you that I know that people are dying from what's going on. And I know that people might not show a single thing. But I could probably show you some things maybe that might be happening that you just might not be able to see or know about.
To their blood specifically.
I could go after that in 24 ways without any problem. It would just be their blood. I could talk about your whole body and all the ways that it is both conceivable but also substantiated by work. I mean actual work, laboratory work, analysis work. I can go over a couple dozen ways in your body that I would expect to see and have effects. The bone system, the skeletal system, okay, I expect problems there. The neural system, cognitive, I expect problems there, okay? Thyroid, your regulator, I expect problems there. When I say expect problems, it's because I see problems.
A fascinating topic of discussion between us has been that you've actually speculated that there might be some positive aspects to this organism if you were able to control it and have it to do its thing in some ways. Could you talk about a few of what those could be?
Examples would include that of energy production. There are serious questions that can be entertained here about the potential benefits of energy production resulting from electron transfer in microbial growth. And these fields are going on. That's why I'm interested. I know that there's work taking place, and I study my work and I say there could be an association here. So one is energy production. Another would be biodegradable materials, essentially plastics that would break down, polymers that would break down, instead of your water bottle here that's screwing up the junkyards for the next 20 years or whatever. There is absolutely a future that we'll see these products breaking down. There is work going on, and it will happen. It can't keep dumping the way we are. Because there's polymer formation within this growth process, I would certainly conjecture that there may well also be a means where, since it's biological, I know the polymer formation is biological, there is a real possibility that it could go the other direction if you learn to control it, where you could have polymers that would break down. A third would be that of waste decomposition. Sewage, the junkyards of the world. And look at what we're doing. You cannot sustain the planet with what we're doing long term. So you have to come up with smarter ways, right? I'm suggesting that there may be avenues for an investigation of waste decomposition in general, not just plastics.